Hello everyone, and I'll start this next session very soon. It's almost 4 p.m. So before we start the next session, just a quick update in case anyone has any doubts. Feel free to ask before we start the lecture.
Hello, sir.
Yeah.
Sir, I have a small doubt. In yesterday class, we have used just before lambda function, we have used if-else condition. So in that if condition, we just mentioned x of some variable. So that condition should be complete, means that x of equal to 0 or not equal to 0. But you didn't mention something. So how that if condition is working?
Here.
Yes, sir. Other sense.
Oh, okay. So basically what happened was when I ran this yesterday, when this other cells, when this is 0, it was giving me a divide by 0 error. So what we had to do is we have to first check if this is greater than 0. This is a simplified way of saying not equal to 0. This if condition. So
Okay,
if
sir. Got it.
I write it like this, and if I write the short form like this, it means the same thing.
Okay. It is by default like that. Okay.
Exactly. See,
Got
actually,
it.
this actually means is x other sales equal to true? Now, if it is 0, then that is cast as false. If this is not 0, it is cast as true. So if it is not 0, this condition evaluates to true.
Okay, sir. Got it.
Any other doubt? Okay, so I will get started with this lecture. So as before, we will do our imports. And we will read the file. Interesting. Anyone knows what this is?
You can disable annotation in the settings,
I see.
in the second settings.
Okay, interesting. I didn't know that. Okay, so we are now back at this. Okay, so this is our data frame. So in this lecture, what we're going to talk about is what are called joins. All right. So first, what we'll do is let us come up with two different data sets. So for that, what I'll do is I'll use what we did before. So what that means is, let me create one data frame. I'll call this a data frame df1, and let me say this is vd df, and here I will do group by name. I will choose NA sales and global sales. And to this, I will do me. Okay, so this is one data frame. So to give you what this is basically a data frame where we have grouped together all these. Actually, what I will do, let me do a sort as well. No, let me do by is equal to NA sales and ascending is equal to false. So now if I say df1, this should give me the way we expected, that is WII sports. So this is our head. Now let me just copy this and create another data frame. Only thing here is we will group by name, but we need only the year. So I can just remove this list and just put one here. And instead of doing mean, let me do max. Okay. So here we don't have to sort the values because it doesn't make much sense anyway. All right. So all we have to do is, so let's check these two data frames. Oh, sorry. So these are our two data frames. Okay. So if you want, of course, we can also do the same thing here as well. That is, we can just put sort values is equal to ascending. I mean, in case. Here you can't put by is equal to North America sales because that column doesn't exist, but you can do this. Right? So this starts from 2020. Right? So does anyone have any doubt about what I did? I just created two sample data frames. All right. So why am I doing this? Now, what I'm trying to say is, let me just write out a few things. What I'm trying to talk about is the concept of join. So when you use a join, you have two data frames. All right. Now, historically, data joining comes from SQL or SQL. In SQL, when you have two different tables, you can join two tables having different columns to create one larger table. Okay, this is what it was. Now, joining is also a similar way when you can combine two data frames to form a larger data frame. So for example, we have a data frame DF1 with these two columns, North America sales and global sales. We have another column, or rather we have just, actually, you know what, maybe I should make this into a data frame so that it will be easier. So let me put a data frame and we can just put by is equal to year. So now this is also a data frame. So we have one data frame with North America sales and global sales, and we have another data frame with just the year. Now, both of these will have the same index, right? So for example, let's go and check that. If we say info, you see it has 11,493 rows. And if we say info on DF2, why is it showing series? Data frame, sorry. So this is also a data frame and it has 11,493 entries, right? So here you see it has only 11,360 non-null, but otherwise the total number of columns is the same, or rather the rows is the same, 11,493. Okay, so what I'm trying to say is these two data frames have the same index, but they have two different columns. Now, the question is, supposing I want to join these two data frames and have another bigger data frame with three columns, North America sales, global sales, and year. For this, we will use the join statement. Okay, so here I'll stop for a minute. Does anyone have any doubts about what I'm trying to do?
So do you have any control of how you join them?
Exactly. So now these are the things we are going to talk about. So let's talk about how we'll do that. Now, I'll just write here, in join is just like basic set manipulation. So for example, you might know from basic mathematics how we have, if you have two sets, you can take a union, you can take intersection, as well as you can take a left union and a right union. All right. So this is very similar to setTL. So let me give you some examples. Let us say first, let us actually take another one. So let's say df3 is equal to df1 dot ilock, and let me take a smaller subset. Okay, so let me take 0 to 20. So if you see now, df3 is basically just 20 numbers, right? Just for our convenience. And let me just take the same thing for df4. So let me say df4 is equal to df2 dot ilock 0 to 20. And if you see df4, this is also the same thing. Okay. Now, if you see, there is something you might notice. These two indices may not be the same. Okay, and we'll talk about that very soon, right? Because that's the idea. I want to give you examples of how this works. So what is important is we want to join these two. So let's try out some joins. Supposing I say df3. Now for that, what we do is you use the join method. So let's look at the help as always. The join has this structure. So for example, you can use the join method on any data frame. The first argument is called other. Other means this is the other data frame. So like you said, you are always doing join between two data frames. So the first data frame is the one that you are actually passing the method on, and the other is the argument that you are passing as. Okay. Now, on is how you want to do it. Like the question was just asked, can we control how you want to join two columns, right? Or the other two data frames? And the answer is yes, you can control it by using this on, right? Now, the next is how, right? And we'll talk about this very soon. And after that, there is left suffix, right suffix, and sort. So let's go through all of them one by one. We already talked about other. Other means this is the second data frame. What is on? On means that you are telling it either one, it is a column name, or it is an index name. Okay. Now, why am I saying index? In this case, we have a single index, but in some cases of data frames, and we'll see that soon, you can have multiple indexes. So if you have multiple indexes, you can specify one index, right? If you don't specify anything, then it pretty much uses just the row names, that is the index names. Now let's look at how. There is left, there is right, there is outer, and there is inner. Okay. Now what is left? When you say left, and that is the default, it will take df3, it will give back all the rows of df3, that is whichever is the first data frame, and it will give back all those elements of the right data frame which are also present in df3. All right, so let's start doing it and looking at it. So let's first see what on. Let us say how. So we are going to leave on is equal to blank because we use only index. Later on we can check out some other examples. So first I will say df4 how is equal to left. All right, now let me give it another example. Let's say x1. Okay, so this is what we have. What is x1? Now you see what has happened. It has given back all the rows of df3 and it has given here NaN. NaN means not a number. Why is this so? Can anyone tell me why?
None of these entries were in df5, so just put it as NaN here.
Exactly. I mean df4 to be exact.
D4, sorry.
So now I will do this again on df1 and df2 and tell you how that changes. So like for example, let's run x2 on df1 and df2. So these are the original data frames, right? Now let's see what we get as x2. Now you see you get something. All right, but again, if you look, we are only having a large number of We don't know how many are there. So for example, if I say, let's say I lock 0 to 100, let's give an example. Actually, it's just not printing it out. So let me just say, what if I say print? I would like to show if it is larger. No. Okay, so let me just use the head method. Let me say if head comes in. I'm trying to see if there's a larger way of. No. So what I'm trying to say is, you see here, now it has filled up the columns. All right. So we do have a year, and it does appear like it's filling up. But it's important to understand here is there will be several NANs depending on some rows which are not present. Now, in such a case, however, because DF1 and DF2 have the same index, all right? Because remember, if I say DF1 index and I see DF2 index, these two are exactly the same. They have length 11493, and these are the names of our data frame. These are the names, these are unique names in the data frame. So therefore, when you are doing a left join, you are actually just joining whatever is there. You are actually doing a complete intersection. The reason is because the rows are common. Does anyone have any doubts about what I said? Because I'm going to give you another example where we will talk about this in a little more detail. Okay, so let me take that example as before. Actually, I should probably take, let me take df3 to be a little larger. So let me say df3 is equal to df1.ilock 0 to 100. Sorry, video df1, and df4 is equal to df2.ilock 0 to 100. So let's see what df3 and df4 are. So this is df3, right? And this is df4. Now let's run this. Let's run that command again. And you now see the NAN showing up. So the problem with this method is it is tough. For example, if I say df3 and df2, now you end up seeing a lot of joins with respect to the year. The reason is because every index of df3 is present in df2, right? But if I do df4 by df1, now it will not be the same. You see, it is totally different because now I'm doing a left join with respect to df4. Does anyone have any doubts about what I'm saying? Right? See, it is how you perceive the left join and the right join. For example, if I say df4, df4 has only one, that is year, right? And df3 has North America sales. So I can join df4 with df3, taking the left data frame as df4. So this is what I did. And you see, when I do this, the year appears first and the North America sales and global sales appears later. So I hope
You
this
have
is
one, I think.
what is it?
Not DF3 in input 42.
Yeah.
You have.
Oh yeah. Sorry. So if you do df3, yeah. So now again you see it's all NaNs because the rows are not common. Now, we've been doing left all this time. Let us do intersection. So let me say x3 and let's look at the help again. You see, the other is inner. Inner means intersection. All right. So let's do inner and tell you what that is. So inner is like when we take the intersection of two sets. And can anyone guess what this will be? It's a blank data. The reason is because there were absolutely no rows common between the two of them.
It's a Venn diagram intersection.
Exactly. It's a Venn diagram intersection. So just to complete this, let me give you another example. We'll talk about the other two. The other is what is called outer, and this we know as a complete union, right? So left set, right set, the entire thing, everything mixed together. But there's one little trick which we should talk about. So if you look at X4, you will see that both of them have NaNs. There is NaN on the year and there is NaN in global sense. The reason is because we are taking a complete intersection. There are some cases, there are some values of rows for which DF4 there are no values. And in some cases, there are values of rows for which DF3 has no value, for no values. So whenever there is a value missing, it appears as NaN. This is a complete Venn diagram intersection union. Does anyone have any doubt about this?
If both the data frames have a common row and we do the outer join, will it just return duplicates then?
Oh, no. If it is, yeah, okay, that's right. No, it will not return a duplicate. If there are common rows, then in that case, it will add the columns together.
What do you mean by add the columns?
Okay, I think what it is. Let me give you, what I'm going to do is, let me go and choose. I'll just go, I think because what you're saying is one column is common between the two of them, right?
No, I mean if the entries are supposed as like both the data frames have common rows is what I mean, a common index rows.
Oh, okay. Common rows is pretty simple because what happens if you take a common row, this is for intersection or union?
Union.
So if you take for union, then for example, if the rows are common, then the values will be appended. So for example, North America sales and global sales, let's say for this value of row, there is a value, right? So in that case, you will get the entire column, entire row as actually non-zero or rather non-NaN numbers. They will be actually finite numbers. Because then you're just appending the two columns together, these two columns to this column. Then it's just a join. Okay, like what I'm trying to say is, for example, let's say DF3 has this value 2016.0. And let's say for this same value, the actual values were rather this one, 41.94 and 82.74. In that case, Ace Attorney 6 will turn out to be 2016.0 and these two values here.
All right.
Is there any other doubt?
Just one clarification, NaN appears usually when?
NaN appears when for a particular row that you're joining, there is a value in one of the data frames, but for that row, there is no value in the other data frame.
No value at all. Okay.
Right. The reason why this kind of happens is because, like, for example, you will get data from like maybe two different SQL tables. And when you get it from two different SQL tables, they may be for totally different times. So for example, you might be mixing the data of sales data of February with the sales data of March. So the result is, if all the rows are related to the dates in which you took the sales data, then you will have two totally separate different type of rows. So all your values will not match at all. So therefore, for all the values of February, in the other data frame, you will get NANs, and in the first data frame, you will get NANs for all the values of March.
Okay, got it.
So the main application of this data frames DF, basically joining, is when you're extracting data from different sources and you're combining them together to form a larger data frame. That's the only major application. Other than that, typically we don't really use it so much, because if you're having the same, like what I did never happens. I took one data frame and I broke it up into two parts. That usually does not happen. Usually you take two separate data frames and combine them together. So is there any other doubt? So if there is no other doubt, what I will do is, there is not much. This is pretty much just set theory, right? Like Venn diagram set theory. And all you have to do is just look up this help of join if you need to know how to join. Usually, like I said, this is usually the case, and you will see this happening when you get, like, for example, if you ever apply for data science jobs, or even if you're looking for a challenge on Kaggle, sometimes what might happen is that there'll be several data frames that you have to mix together. When that happens, when you want to mix them together, you just have to read them as separate data frames and use this join to combine them together, right? So what's important to note is that there are 4 different ways of joining. So look into how you want to join it, whether you want to do an inner join, which is an intersection, an outer join, which is combining everything together, or you want to take one of them as the reference and combine the values of the other to this data frame, right? So that is pretty much all there is to it. So if you have any doubts, please do ask. Otherwise, I have another 5-10 minutes. So I'll just start the next topic. We won't be able to complete, but we'll carry it over. Any doubt? Okay. So if there are any doubts, you can always interrupt me, no problem. Otherwise, I will just start talking about the next thing. So up till now, for example, if you take video DF, let's look at the head. You see that we have a data frame with several columns and we have an index, right? So let us look at the index. The index is basically a range index starting from 0 going all the way to 16,598, right? So basically it is integers from 0 to 16,597. Okay, that's what it means. Now, this is a case of what is called as a single layer index. The index is just one layer. In exactly the same way, if you look at columns, this is also, if you look, this is an index object, right? You look at the type. Let me just copy it again. Oh my God. Okay. You see, this is a separate object, right? And the same, let me just do it for this one. Also, it is a range index. So these are separate objects in pandas specifically for creating indices, right? These are not usual Python series or Python arrays. These are actual objects called index objects, and they're different types. For example, there is a normal index, there is a range index, and we'll see soon there is also something called multi-index. So at this point, I'll stop for a minute. Does anyone have any doubts about what I talked about? Okay, so now we had already seen, for example, we had seen df1, right? Now we had seen df1 has another index. So let's check out the index of this df1. Oh, sorry, df1. And you see this is also of type index. So let's check it out. Let's confirm that this is indeed the case. And you see it is also an index type. So now what I want to do is I want to create a multi-index data frame. Okay, before that, I'll just stop for a minute. Does anyone have any doubts about what we're talking about? Okay, let me continue. So let us take this data frame. Let's do df head. Up till now, we had done a group by on the name, and we found that there were some amount of unique names. Okay, now what I'm going to do is I'm going to do a group by on 2 columns. Let's choose these 2 columns, right? Okay, let's do that. So let's call this video df group. Let's call this group 1 is equal to video df dot group by. Okay, let's look at the help points. You see, you can specify a by, and the by can be a mapping or a function or a label or a list of labels. So we can provide a list of columns, right? And that's what we're going to do. What we're going to do, we're going to say explicitly pass the group, say name and platform. All right, this is what I'm going to say. Now if I just say this, what I will get is a group by object. This is a group by object, right? This is just the way we did before, because when you group it, all it does, it just collects the data frame rows separately together, and it creates groups of them. That's all. So that's just a group by object. We need to now specify an aggregator function. So what I'm going to do, I'm going to take the North America sales and global sales. We have to specify another list. And let me do mean. Now, do you see what is happening? We now have, this is the result. Okay, we have 2 columns. We have North America sales, we have global sales. But you see here, we have 2 indices. There is name and there is platform. Okay, if you go back up and see, we had only one index called name. Now, because we are doing a multi-group, that is, they're grouping by 2 columns, it is giving us a multi-index. So to check this out, let me just do, okay, let me do y1. And let me look at what y1 is. Same thing. And let me look at the index. And you see what we get. We get another object called multi-index, right? And you see this multi-index is an object which is a list, and it is a collection of indices. So for example, there are 2 indices for each one, like this. One is the name and the other is the platform. So here I'll stop for a minute. Does anyone have any doubt about what we did? Okay, so the reason why multi-index is good, right? So for example, whenever you reference any row of a data frame by its index, the the processing is fast, right? On the other hand, if you try to extract information from, for example, if you want to find out, let's say, something about this data frame based on name and platform, you would have to do a query. All right. So for example, let's say I want to find out this one. Which row has name Mario Kart WII? So let me just copy this. And let me say the platform is WII. Right. So what I want to do is I want to find out which row of the data frame has the name Mario Kart WII and has platform WII. So for this, what will I do? I need to write a query. I need to write a query saying video df name is equal to Mario Kart WII. I need to close this off in parentheses, say ampersand, and then again video df platform is equal to WII. All right. Now to this, I have to then pass this to my data frame. Okay, and I'll just comment these out because they are not executables. So this is what I have to do. I have to run a query, right? So I want to find out which row of the data frame satisfies this particular query. That is, the name is equal to Mario Kart WII, the platform is WII. So if I run this query, I get back this one thing. Now, there is nothing wrong with this query, right? The problem is this query is a fairly slow way of processing. If we know that a lot of our searching is based on name and platform, then it is advisable to create a separate data frame with these two as indexes. Now, when you search by index, it is much faster. So does anyone, I don't think I can give you the example here. So I'll just stop now and ask if anyone has any doubt about what I did. It is like similar to like searching for a book in the library. So for example, if you're just told, okay, this is the book, right? And you have to search the library for this book. And there is no sectioning within the library. So all you know is the books are just arranged in alphabetical order. Then your job is you have to search for among the books according to alphabetical order. That's it. On the other hand, if let's say the books in the library are arranged according to departments, within department specializations, all those things, it is much easier for you to find a book. The reason is because if you're looking for a particular book, you know that book belongs to the department within the specialization. You don't have to go searching the entire library. You can go straight away to that section. So your searches are much faster. And that's exactly the same concept in a data frame. When you create a lot of indices, you make your searching faster. So I'll just stop now. Does anyone have any doubt? So we are almost out of time. If there are no doubts, then I will just say goodbye. If there are doubts, please do ask. I can't be sure if I'll be able to answer them. But otherwise, as usual, the video will be uploaded on YouTube and we will meet tomorrow again, where we will complete this and I'll show you how we can extract data from indices.